हाय एवरीवन, वेलकम टू केमिस्ट्री। मैंने लास्ट क्लास में फंडामेंटल्स ऑफ थर्मोडायनेमिक्स और टाइप्स ऑफ सिस्टम्स के बारे में डिस्कस किया था। अगर आप उस क्लास अभी तक नहीं देखे होंगे तो आप एक बार जाके देख लेना, बिकॉज आई एम गिविंग क्वेश्चंस ऑफ लास्ट क्लास हियर। इफ़ यू वांट टू डू दीज क्वेश्चंस, राइट, इफ़ यू वांट टू डू दीज क्वेश्चंस देन यू हैव टू फॉलो दी लास्ट क्लास। सो पहले एक बार जाके देख लेना, नोट डाउन दिस all questions in your notes, do the questions and give your answers in the comment section. Okay, so first of all take the screenshot, right? Okay, now today we are going to discuss about intensive and extensive properties. Okay, damn sure I'm going to give you 20 to 21 examples here. After this class you will get a very good command on extensive and intensive properties, trust me. Okay, so listen carefully, watch the class till the end. Definitely I hope you will enjoy the class. If you really enjoy the class, please tell something in the comment section, and don't forget to subscribe the channel. Please subscribe. Why I'm asking you, because if you subscribe the channel then it is some motivation to me, right? It is some motivation to me. It will motivate me to make more and more videos. Please don't forget to subscribe. Thank you so much. So I'm starting the class now. Intensive and extensive properties. So first of all, if you go through the definition, textbook definition, it is okay. Generally we discuss about the textbook definition, but don't worry, I will explain you on my own so that you will get more clarity on this. First of all, साइज पे डिपेंड हुए प्रॉपर्टीज को एक्सटेंसिव प्रॉपर्टीज कहते हैं, राइट? साइज पे डिपेंड नहीं हुए प्रॉपर्टीज को इंटेंसिव प्रॉपर्टीज कहते हैं. Not only size, actually I am telling size, but you can take in place of size, you can say mass or matter too. I am writing the definition first. See, extensive properties. Extensive properties intensive properties. Properties which depends on size of the substance, size, or we can say mass, or we can say matter, right, of substance is known as extensive property. Properties which does not depend on size again, or mass or matter of substance is known as intensive properties. This is the textbook definition, but we don't go through this definition. I will explain you more clearly. See, so these are the definitions you can write in your notes, right? So actually what is extensive and what is intensive? Okay, definition तो ठीक है, लेकिन what is extensive and what is intensive? देखो, first of all I am giving one example here. So first of all, length, right? So length. So if you take the length, first suppose you take the human body, right? You take the human body. This is me, this is Krish, okay? These are the legs, okay? Now I'm bisecting this person into two parts. Okay, so initially this person length, for suppose it is me, my length is 5 feet 8 inches. 5 feet 8 inches. Now I'm bisecting this person into two parts. Okay, if you cut this person into two parts, now I have two parts. So first part is this. First part is this. Second part is this. Right? Second part is this. Now, totally initially 5 feet 8 inches. 5 feet 8 inches. Now, this part length is 3 feet 8 inches. This part length is 2 feet. 2 feet. So, totally 2 plus 3, 8. That is 5, 8 inches again. Right? But after bisection, after division, you have two parts here. That means this property is depending upon the size, right? Depending upon the size, initially you have 5, 8, but after bisecting, it is two parts. So this part is 3, 8, this is 2. That means property is changing or not? So after bisecting one object, if property will change, that is extensive property, right? That is extensive property. So length is extensive property because initially 5, 8. So after bisection, length has been changed. Length has been changed. So this is extensive property. Clear? So this is extensive. Next, mass. What is about the mass? So mass, if you take the mass of this person, 55 kgs initially, for suppose. So after bisection, after dividing this person into two parts, now this part has मान लो 30 kgs, right? This part has 25 kgs. So totally 55 kgs. Totally 55 kgs, right? So again after bisection, you have two parts. So this weight has been changed. This weight has been changed. So this is also extensive property. This is also extensive property, right? So it is okay. If you consider as system mass, it is okay. But if I ask you what is about the atomic mass or molecular mass or atomic weight or molecular weight, देखो, for suppose what is about, see, if I take the system, in this system I am taking the water molecule, right? I am saying this system is at, for suppose 10 grams weight, initially 10 grams. So after bisection, I have two parts, I have two small parts, right? After bisection of this system, I have two parts. Now in this part, मान लो this water molecules 5 grams and here water molecules are 5 grams. It is okay. So I am talking about the system mass so that it is extensive property. But if I ask you the mass of water, the molecular mass, if I ask you, anything changed? See, water here 18 grams, here also water 18 grams, here also water 18 grams, here also water 18 grams. That means molecular mass has not been changed. At the same time, if you take the atomic mass, oxygen 16 grams, here also 16 grams, here also 16 grams. That means molecular mass and atomic mass has not been changed on bisection or on division. Only mass has been changed, not atomic mass or molecular mass. Clear? So molecular mass and atomic mass are intensive properties because after dividing one system, if properties has not been changed, that is intensive property. So here you have to remember molecular mass and atomic mass, these are intensive properties. These are intensive properties, but mass is an extensive property, right? Next, mole. So what is about the mole? Simple. See, again I am taking the system. मान लो here there is a water, right? So initially I have 5 moles of water, right? So 1 mole water contains Avogadro number of molecules. So 5 mole water, 5 into Avogadro number of molecules. So here I have 5 iitjee molecules, right? I am dividing this system into two halves, right? 2 parts. Then I am getting this 2 parts here. Again, here there is a water, here there is a water. Now I am saying in this part 3 moles of water is there. In this part 2 moles of water is there. That means 3 iitjee molecules are there here. 2 iitjee molecules are there here, right? 3 iitjee molecules, 2 iitjee molecules, means after dividing this system, properties has been changed, right? So mole is extensive property. Mole is extensive property. Okay. Next, volume. So what is about the volume? Take my body, okay, cut me like this, cut me like this, or cut me like this. Volume has been changed or not? Volume depends on the size of the container. For suppose you take water bottle. If you have this size of water bottle, big size of water bottle, you will get 10 liter water. If you have the small size of water bottle, you will get 5 liter water. That means volume of the water depends on the container. If you take the system, initially this is 10 liter water, volume is 10 liters. After bisection, 2 parts. In these 2 parts, small containers, 2 containers now are small. So you will get 5 liter water or 3 liter water in one container. Remaining 7 liter water in another container. That means properties has been changed. Volume property has been changed. So it is also extensive property. Clear? So volume is extensive property. Volume is extensive property. Next, area. What is about the area? Simple. Again I am taking the system here. So initially area is high. So after bisection I have 2 small parts. So area is less. That means area is also extensive property. Area is also extensive property. Next, density. What is about the density? What is about density? So density equal to mass by volume. Density equal to mass by volume. देखो, here I have to mention you one point, very important point you have to remember. If important point, note down, extensive by extensive equal to intensive. Okay, extensive by intensive, neither extensive nor intensive. So here you have to go through the concept, right? Again, intensive if by extensive, again either extensive or intensive. So here also you have to go through the concept. Clear? These points you have to remember. Now see, here if you see density equal to mass by volume, this is the formula. Now mass is extensive property, volume extensive property, so density is intensive property. How can you explain this density? Through concept. देखो, you have in one container you have honey, right? मान लो honey density is 5 gram per liter or 5 gram per ml, right? So after dividing this system, I have 2 small containers now, but still this is honey. In the container only we have the honey, so honey density has not been changed. If you divide me like this, in this part I have the blood, in the bottom part also I have the blood, so blood density will not change. Even if you divide me, blood density will not change. So density is same. Here also 5 gram per liter. Here also 5 gram per liter. So density is an intensive property. Okay. So it is not been changing. So density is intensive property. Right. So next one. Volume का brother. Pressure means force per unit area. What is about the force? So if you see the force, you take the gas molecules, right? If you take the gas molecules in the container, now suppose you are dividing one container. Now you have the 2 small containers, right? But the strength of the gas molecule, force of the gas molecule is same. For suppose, take me as an example. I am writing geoscientist exam. In geoscientist exam, they will, mains paper is there, descriptive paper. No matter which size of paper they give me to write, but my strength is same. Even if you give me big size paper or small size paper, I will write efficiently, right? My strength will not change depend upon the size of the paper, right? So here also, if you take the gas molecule strength is same. Even this is the big container or the small container, force of the gas molecule is same, right? Force per unit area is same. Per means if you take the 1 centimeter cube area, in 1 centimeter cube area, force of the gas molecule is same or not? Same. So it is not changing. So force per unit area is intensive property. That means pressure is intensive property. Next, temperature. Or you can say, what is about the force? Force equal to mass into acceleration. So mass is extensive property. Acceleration means one kind of speed. So speed will depend upon size, right? If I have the 55 kgs, I cannot move fastly. If I only 20 kgs person, if I am the 20 kgs or 30 kgs person, then I can move fastly, right? So speed depends upon the size. That means extensive property. So this is extensive property. So totally extensive. That means force equal to extensive property. So I can write here extensive. Right? We know area. So area is extensive property here. I already discussed this. So extensive by extensive equal to intensive. So I discussed this conceptually as well as this trick. Okay. Next one. Volume key sister. Temperature. So temperature, for suppose you take my body temperature. For suppose I am in fever. I have 102 degrees Celsius. If you divide me like this, right? Or if you see my hand, so the temperature of hand is 102. If you take my nose, temperature of nose is also 102. So on division or on bisection, temperature of the system is not changing. So temperature is intensive property. Right? So next, heat and work. Here I have to mention one point. Very, very, very important point I have to mention here. Here you see heat and work. These two are path functions. Remember, extensive and intensive properties depends or follow state functions only. Very, very, very important point. Okay, आप अपने notebook पे note कर लो, right? So these are path functions. So only extensive and intensive properties follow state functions. So heat and work are path functions. So heat and work are neither intensive nor extensive. Very, very important point. Definitely it will come in the exam. right? So heat and work are path functions. So when heat and work are path functions, these two are neither intensive nor extensive, right? Neither intensive nor extensive. You have to remember, very important. So heat and work is the ninth one. Heat and work is the ninth one, right? Heat and work, neither extensive nor intensive. Next, very important point, all energies, all kind of energies you take, all kind of energies are extensive, right? All kind of energies per mole or per gram are intensive. How? You take Gibbs free energy. You have to remember all kind of energies. You take kinetic energy, or you take potential energy, or you take Gibbs free energy, or you take Helmholtz energy, or you take internal energy, right? Or you take enthalpy. So all kind of energies are extensive. But if you take per mole, first suppose I am taking the internal energy. I am taking the internal energy 5 kilojoule per mole. So 5 kilojoule is my energy here, mole. Now this energy is extensive property, right? Mole is also extensive property. So extensive by extensive we know intensive. So that's why energy per mole, or you take energy per gram. Gram means weight. Weight is also extensive property. So extensive by extensive equal to intensive. So all kind of energies are extensive. All kind of energies per mole or per gram is intensive. Okay, right. So after this, again very important point. Again very important point. That is, if you see this kind of terms, specific amount, for suppose given in the question, or standard, or any constants, or intensive properties, or these three are intensive properties. For example, what is about the specific amount? For suppose I am taking here heat capacity. So what is about the heat capacity? What is about the heat capacity? The amount of heat required to rise the temperature of a substance by 1 degree Celsius, right? So how much amount of heat you require, system require to rise its temperature by 1 degree Celsius? It depends upon the size of the size of the matter, right? If you have the large size of matter, then it needs more heat to rise its temperature by 1 degree Celsius, right? So it depends on the size, or it depends upon the mass. So heat capacity is an extensive property, right? But if I ask you molar heat capacity, or if I ask you specific heat capacity, what is about these two? Molar heat capacity means heat required to rise the temperature of 1 molar substance. Specifically, I am mentioning the amount here. Specific heat capacity means heat required to rise the temperature of specific amount of substance. So I am mentioning here the specific amount. So these two are intensive properties. Right? Okay. So after this, standard. So first suppose standard cell potential E naught cell, right? So delta G equal to, we know this formula, NF E naught cell. So E naught cell equal to delta G by NF. Okay. So delta G is the energy, so extensive property, right? So NF, so Faraday into n number of moles, that is charge. So charge means positive charge and negative charge. If you, for suppose you have NaCl solution, initially you have NaCl solution, Na plus and Cl minus ions. Now after bisecting the container, you have the two small containers. So in this also less number of molecules are there, right? So in one container, for suppose initially you have 5 NaCl molecules. After dividing the container, in one container you have 3 NaCl molecules, in another container you have 2 NaCl molecules. That means positive and negative charges are less in one individual container. That means positive and negative charges. So charges depends upon the size of the matter, size of the substance. So charge is extensive property. Charge is extensive property. So extensive by extensive, intensive. So standard cell potentials are intensive. So this is the example of standard. Next, any constant. So you take gas constant, Avogadro number, Boltzmann's constant, equilibrium constant, anything, right? Avogadro number, Boltzmann's constant, gas constant, equilibrium constant, any constant you take, these are intensive properties, right? So next one important thing, entropy. Entropy is nothing but disorderness. That means it depends upon the number of molecules. So if number of molecules will increase, disorderness will increase, entropy will increase. If number of molecules will decrease, entropy decrease. So initially I have the system, right? So in this 5 water molecules are there again. I am dividing. So here 2 systems. In these 2 systems, here 3 water molecules, here 2 water molecules. That means number of molecules are decreasing, entropy is decreasing. So this is the next one. Last but not the least, boiling point. I take the system here. Okay, I have the water. So here my boiling point is 100 degrees Celsius, or melting point, or freezing point, anything. So again bisection, dividing. So I have the 2 small. So here also there is a water. So substance has not been changing. So here also it is 100 degrees Celsius boiling point. Here also 100 degrees Celsius boiling point, right? So it is also, so on dividing the system, the property has not been changing. So it is intensive property. So boiling point, melting point, or freezing point, these are intensive properties. So these are the examples of intensive and extensive. I hope I have explained you very clearly, right? So if you have any doubts, please ask in the comment section. I will give you the practice questions in the next class. Okay, so don't worry. So that's all for this video, and don't forget to subscribe. Please like and share the videos. Thank you so much. That's all for this today. Have a nice day. Thank you.